Hello guys, as usual stay home, stay safe and do excel chemistry. Alright, so I gave you a small task for all of you guys. Okay, I don't know how many of you have done. Hoping that you have done. In fact, if you have not done, then it shows your character regarding studies. Okay, so I use the word character because don't it's not a like a harsh word, but that will help you understand your stand towards the studies during the uh, tough times like this. Okay, so if you are lethargic and if you are not interested to take down a small point, see differences. I asked to write the differences between the boron and aluminium. It's a very small task. Okay, be it lazy or call it that you have some other works to do, or thinking that anyway sir will tell, that's why I did not do. So all these are reasons for you to be not doing the task. Okay, as long as you are having the reasons, you are losing, remember this. Okay, so never have any reason, okay, to for that kind of things. I would suggest you even now, okay, as soon as you hear to this, pause the video, at least make some differences, okay, and then check yourself with the differences that I'm going to show now. Anyways, I'm going to show now, but I would suggest you is do the task, do the work that is given to you, very small task. Okay, so anyways, it's a very short video again today's also, only the just differences, and in the next video we'll talk about the boron and its compounds and aluminum and its compounds. So hopefully with the two important areas that is left over in this chapter, boron and its compounds, aluminum and its compounds, and with that the chapter will be done. But those compounds are some are really important. Okay, so anyways, if you have not done, I would suggest you pause the video at least now, make out some differences and then continue the video. Okay, so those who have done, very good. Like some of you have sent me the differences on WhatsApp as well, very good. So keep your interest pumping up like that. Okay, don't lose your interest after some days or like that. Fine. So as long as you are following the things in a way that I am telling you, by the end of the second years you'll have a great confidence. Ultimately confidence matters. Okay, so even the small things that you are able to do, that means you can do the bigger things also. Okay, fine. So as of now, the differences, yeah, I have written the differences for you, and here are the differences. In fact, we have already studied most of the properties, just rough recapitulating the things. Okay, so dissimilarities between boron and aluminium. So we know, like, the boron is a non-metal, it's a non-metal, and aluminum is a metal. Fine, because it is a non-metal, what do you expect the conductor of heat and electricity? Will it be a good conductor or bad conductor? It's a non-metal, so non-metals are generally bad conductors of heat and electricity. Same way, on the other hand, metals are good conductors of heat and electricity. That's the difference. Very simple. Okay, so you need not by heart the differences. If you can understand the basic things, you can write the differences on yourself. And it has very high melting point. In fact, 2300s of degrees Celsius. It has very high melting point out of all the metals that we have. Okay, and that is boron family, we have 2300 degrees Celsius, very high melting point. On the other hand, aluminum is very low melting point, completely opposite. Okay, drastic change, 600 degrees only. Fine, and it shows allotropy. What is allotropy? Again, what's the definition of allotropy? Having same like elements having same atomic number but existing in different forms. Okay, same element existing in different forms. So boron exists in amorphous as well as crystalline. Okay, what is this again? These are the words that speaks about the solid state. Okay, in solids we have two kinds, crystalline solids and amorphous solids. which we'll study in 12th standard. As of now, yes, boron is exhibiting allotropy, that is crystalline boron as well as amorphous boron. Okay, whereas aluminium, there is no allotropy at all. Fine. Then talking about the reaction, no reaction with HCl and dilute sulfuric acid. We have seen this reaction, like this point as well. What is that? Boron does not react with non-oxidizing acids, like HCl, dilute H2SO4. But with concentrated H2SO4, concentrated nitric acid, yes, it do react and liberating the nitrogen dioxide and sulfur dioxide, which we have seen that reactions also. So on a whole, point is no reaction with HCl and dilute H2SO4 for boron, but on the other hand, it dissolves, aluminum dissolves in dilute HCl and sulfuric acid to liberate hydrogen gas. Okay, so in fact, aluminum plus H2SO4 or HCl, when you react, it forms aluminum sulfate, Al2SO4 thrice plus H2 gas. This reaction also we have seen earlier. Okay, so that's the main difference. And in terms of nitric acid, boron, what happens? What would be the reaction with boron in nitric acid? What should have happened? This also we have seen already. It forms plus NO2, one of the very important reactions I have told you earlier. And on the other hand, with nitric acid, this is the reaction, but with aluminium, it becomes passive towards concentrated nitric acid. What do you mean by passive? Passive means the metal does not react after some time because the formation of Al2O3 around the metal. Suppose this is my metal aluminium and this is covered by aluminium oxide, and when it is covered by the aluminium oxide, the metal, then the concentrated nitric acid will not show its impact, or it will not show its reactivity on the metal. Okay, so that's what I call it as passive. And boron with magnesium, this also we have seen very recently, it forms borides, Mg3B2. And on the other hand, aluminium, does aluminium react with the metals like this? No, they don't react, but they mix, or they tend to form a very strong substance, that is alloys with metals. Okay, and H3BO3, that is, it's a weak acid. Hydroxide of boron is a weak acid. Hydroxide of aluminum is a amphoteric in nature. That means it can react with both acid and base. We have seen it already. And its covalency is 4. Aluminium's covalency is 6. Why is it exhibiting 6? Because since it can use the empty d orbitals, it has the availability of empty d orbitals, whereas boron, no empty d orbital, so its covalency is limited to only 4. Okay, then hydrates of boron, what is the nature of hydrates of boron? The hydrates of boron are all covalent in nature, whereas aluminum hydrates are very much less stable. Okay, that is, in other words, you can say like no hydrates that are stable hydrates are formed. Okay, there are no stable hydrates that are formed. Okay, so that is one of the differences between these hydrates of boron and hydrates of aluminium. And as far as halides, BX3 exists in discrete form. What do you mean by discrete form? Discrete means individually. Okay, not in polymeric or dimeric form. Okay, BX3 exists in discrete form, whereas the aluminium, they exist, or AlCl3, they exist in dimer. Okay, so halides of aluminium, they exist in dimers, and it forms covalent compounds majorly. Okay, boron will generally form what? Covalent compounds, whereas aluminium can exhibit or can form both covalent as well as ionic compounds. Strictly speaking, it should form ionic compounds, but those ionic compounds have covalency or covalent nature according to the Fezan's rule. Because of polarization, the aluminum can exhibit the covalent character in it. Okay, and lastly with carbide, that is with carbon, B4C, which is covalent in nature. Okay, carbide of boron is covalent in nature, as I already said. Most of the compounds are what, covalent in nature, whereas the aluminum carbide is ionic in nature. Fine. So these are the main differences between boron and aluminum. Nothing much, very simple. Okay, so again I'm telling you, those who have not done, at least now over, so pause the video, take down these things, take down these points, write it in a fair notes. Okay, and just keep revising the points. Okay, points to remember, that is, can be expected, like assertion and reason, or what are they'll give you 4 statements and say which of these statements is not in relation with aluminum. So such kind of questions can be asked. Okay, so anyways, with this the major part is done. The last 2 parts, that is boron and its compounds, aluminum and its compounds, we are left with these 2 things, and hopefully in the next week we'll finish off this chapter. Fine. So today that's all. Stay home, stay safe.